Another property of materials that's relevant for their thermal characteristics is called the conductivity. That's how well the material transmits thermal energy from one end to another. So here I've got a nice source of heat here I want to be careful with, and I've got two different rods, same diameter, same dimensions, but different materials. This one is stainless steel and this one is aluminum. So I'm just going to hold the aluminum in this source of heat here, and we're going to see what I feel at where I'm holding it on my hand. I'm putting thermal energy into one end of the aluminum, and that energy is heating up the aluminum, and the conductivity of the aluminum is determining how quickly that thermal energy works its way down the aluminum rod. So I'm going to do this like this. So the end of the rod is getting quite hot now, where the flame is applied. We can in fact measure it. We've got a thermometer here, and I'm starting to feel the heat where my hand is. So that means that that thermal energy is being conducted along the length of the rod, and we can see the temperature of the rod end. You can see the temperature is quite high there, well over 100 C. And where my hand is, fortunately not that hot. I would not have been able to hold on to it. But it's starting to get warm, around 60 C, so it's too hot for me to hold now. It's at about 55 C. Now I'll do the same thing with the stainless steel. So I'm going to hold this in here. I'm holding it at the same distance from the end of the rod as I was holding the aluminum rod. And one thing I notice about the stainless steel is that it is denser than the aluminum. It weighs more. There's more material there. And I'm not feeling the heat come up, and in fact, if I move my hand closer to the flame, I'm still not feeling that heat. Even though the end of this is quite warm, that heat is not conducted down the length of the rod as quickly as it was with the aluminum, because the thermal conductivity for the aluminum is much higher than it is for stainless steel. And so, as a practical matter, what this means is in the kitchen, if you've got a stainless steel handle on a pot, it's probably not going to conduct the heat away from the pot as quickly as something like aluminum would. And you can see I'm tarnishing this stainless steel rod here. It's quite hot there, but that heat, that thermal energy is not working its way down the length of the rod as quickly as it was with the aluminum, even though it is very hot. Where my hand is, it's quite cool. And so these different materials have different conductivities. If we wanted to make an insulator, we would make the insulator with a material that has a low conductivity so that it doesn't transmit the heat from a warm place to a cold place very quickly. So for example, if you're putting insulation in the wall of your house, you want something with a low thermal conductivity so that when you heat up your house in the winter, that heat does not conduct through the wall of the house to the outside, or in the hot summer, the heat from the outside does not conduct through quickly. So based on our experiment here, aluminum would be a poor insulator. Stainless steel would be a very expensive but more effective insulator.